Okay, now we're talking about rotational symmetry. Remember I told you to think of rotational symmetry like twisting around a doorknob. Because you want to think about you're going around the axis of the doorknob, like perfectly turning it when you're working with it. Now, we have what's called rotational symmetry. So a figure has rotational symmetry or radial symmetry if it can be rotated about a point by an angle greater than 0 degrees but less than 360. So if the image coincides with the pre-image. That means if I start and stop, it looks exactly like the same thing. You can't really even tell the difference. Well, you can do this by using what's called the angle of rotation. Now again, I'm assuming you remember when we talked about this the other day about rotation and what rotational symmetry was. Remember, the angle of rotational symmetry is always the smallest angle through which a figure can be rotated to coincide with itself. So, for instance, it has to be under 360 when I rotate. So you need to at least rotate it maybe once, right? Because you at least go 180 degrees. But here's how I like this. It says the number of times that the figure coincides with itself as it rotates through 360 is called the order of rotational symmetry. And let's see if I can rewrite that so it's readable. Rotational symmetry. So let's look at this diagram. Here we have a square, and we notice we have it right in the center. If I was to twist around that spot, I would only have to go 90 degrees in order to rotate it. And notice the angle that we're rotating. Okay, you can see we're going left here, going to the left when we do 360 degrees. We'll explain more later about why that works that way. But the angle of rotation symmetry is very easy. You just go 360 divided by, basically, I think you call it the order, how many times you do that. So that's 90 degrees. The order, because I divided by 4, is 4. So I have the 4 for perfect parts, but boy, am I problems, which gets that. So let's keep going on the next one. It says, tell whether each figure has rotational symmetry. If so, give the angle of rotational symmetry and the order of symmetry. So when I look at this diagram, can I sit there and put a point somewhere in the middle and rotate it around? That's a resounding no. But can I rotate this one? If I put it in the middle, can I rotate this less than 360 degrees and land on itself? And the answer should be yes. Okay, why? The angle of rotation, or rotational symmetry, so I call the angle of rotation, is 360 divided by 2, 180 degrees. This point could end up over here with a 180 degree rotation. So what's your order going to be in order for it to go back? Well, the order is what I divided by 2. I twist it twice, once, twice, and got it back to get there. Now this next one is kind of like a warning sign when you're working like a railroad crossing. If I had the R's there for railroad crossing, it would not work. But this one does have, of course, rotational symmetry. You can see it smack dab right here. And you can rotate it how many times? What's your order for this one? We're going to do order first. Yeah, the order would be 4. To get the angle of rotation, you just got to go 360 divided by 4, which is 90 degrees. So I would just rotate. You could easily say 90 degrees. Now you can have multiple rotations. You could have 180, 270. Those are also angles of rotation, but this is the smallest one that I want. The next one is a slow moving like tractor sign or vehicle. And I laugh at this because I grew up with this out in the country as a kid. I remember getting so impatient driving behind farmers and ranchers who were especially hauling either farm equipment or hay or something like that that just took up the whole road because it drove me nuts because I couldn't get where I needed to quick enough. It's kind of like just what you think of large equipment going through a town. But does this one have, if I smack dab, put this in the middle, does it have rotational symmetry? And the answer would be yes. The angle of rotation, or rotational symmetry, is going to be 360 divided by what? 3. So it's 120 degrees. The order, since I divided by 3, is going to be 3. It's pretty easy. The order is so simple. Now here I have this beautiful parallelogram. And it looks like it wouldn't have, it has no lines of symmetry, so why should it have rotational symmetry? Well, I can rotate it 180 degrees and land on itself, and it looks exactly the same. So yes, this one has rotational symmetry. The angle of rotational symmetry is just going to be 360 divided by 2. That's 180 degrees. And my order, because I have to twist it twice, is 2. Now look at this next one, the scalene right triangle. Can I put a point here, here, somewhere in the middle, and get the same thing without going 360 degrees? The answer should be a resounding nope. All right, it shouldn't work. All right, let's keep going. I'm going to go pretty fast with these because I think they're pretty easy. Again, stop, pause, reverse if you need to catch anything else with this. Now the next one. Looking at this, we want to describe the symmetry of each icon. Now these are things that you can find. Like this is the yin and the yang symbol. If you did not have the dark and the light, would you have symmetry here? You can kind of see the symmetry here. You can tell how this one would rotate onto this one. They just switch the color of the graphics when you do this. So they say describe the symmetry of each icon. Well, this is copy and shape. No, just draw any lines of symmetry, and if there's rotational symmetry, give the angle and order. So looking at this, does this have line symmetry? Can I draw a line through it and perfectly reflect onto itself? So this is a resounding no. Now, I'm going to go with rotational. Even though I was really particular with this, with the flag about line symmetry, I'm going to say with rotational, yes, it has it. The angle of rotation is going to be 180 degrees. Now, I should be more particular about this. Probably I should make this be, and you could argue, and I'd give you points, like the colors don't match, so it wouldn't work. I understand that. I was literally physically thinking about the shape itself here. So it's 180 degrees. Your order would have to be 2. Now looking at this one, does this have line symmetry? And the answer is yes. How many lines is there? There should be 4 lines. Where? Going straight up and down, and I'm going to do this very fast, so I'm not going to go through, to horizontal, and then going to the diagonals of the larger one. You should have 4 lines here, okay? Then we have rotational symmetry. All right, rotational symmetry, if I put a point right in the middle there, can I rotate around and get the same thing? Yeah, you definitely could. We could rotate 90 degrees and be able to get it. So rotational symmetry, yes. Angle of rotational symmetry, 360 divided by 4, it's 90 degrees. And then we're going to have the order of 4. Okay? And then last but not least, you look at this, we have a sand dollar. Okay, this is a sand dollar. Or maybe it's a piece of fruit. I'm not quite sure which one I got this from, but I remember working with this. And one thing I asked, does this have line symmetry? Notice this is 1, 2, 3, 4, 5, 6, 7 things, but it still works. If it's the line symmetry, yes, there's 7 lines. And if you draw in the lines of symmetry with this, you will go smack dab through the center of one and going in between for the other ones. You should be able to get here. That one would go here. This one would go here. I got one more. So very good. We have rotational symmetry. Can I rotate this? Oops, I forgot to do one of my other lines. I hope you guys caught that. Does it have rotational symmetry? And my answer better be a resounding yes. What is your angle of rotation? Well, here's the cool thing. It's a fraction. Because if I do that, that's 360 divided by 7, and I'm not going to take the time to get a fraction with this. So it's 360 over 7 degrees. What is the order? The order is 7 because I divided by 7. All right, now we have a few more symmetries we're going to try, and then we're going to keep on going.